For the third lesson of Unit 1, we're going to be talking about one formula, sort of broken down into pieces, but it's really one formula. And this is a formula that you have within your formula packet. I wanted to show that real quick in the video. This is what I'll be showing you in class. But if you go to our Math Studies website, under the first semester, right here you have a document that says Math Studies Formulas. If you download that document, this is what I give you for every test. And so it has a whole bunch of formulas in it. Let me show you what that looks like. So they give you the breakdown at the start of it, right here by section. This is what students get for the IB test. And it's really important that you are familiar with what's in this packet and where they are, so that when you get this on a test, you know which page to turn to that will have the formulas that you need for that specific test that you're taking. And so for the one that we're going to be talking about right now, you would look right here under section 1.2. It's something called percent error. This is the formula for percent error. Should be really simple. All you have to do is plug in the numbers. The key is that you plug in the correct numbers into the correct places. So they tell you what VA and VE represent. So VA is your approximate value. VE is your exact value. And so we're going to be working with this formula only for this lesson. But it would basically come within 3 steps. When you're asked to find percent error, there's 3 operations that you're performing here. The first is to subtract. So you're going to subtract the exact value from the approximate value or the rounded value. That's your first step. Step 2 is to divide by the exact value. And step 3 is to multiply it by 100 so that you turn it into a percent. And so the directions on a test are just going to say, find the percent error, and those are the 3 operations that you do in order to get this formula to work out for you. So the one big thing that students will mess up on for this is putting the approximate value here instead of the exact value. So really important that you identify which value is the exact value and make sure that one goes on bottom. These are in absolute value brackets, so you will always get positive answers out of this. You'll never have a negative percent error. You'd be marked down for that. These are in absolute value, so doesn't matter what's going on up top here as far as which one you put first, because you're still going to turn it into a positive. Just make sure that you put the exact value right here in the denominator. So, like I said, 3 steps for that. And the reason I'm pointing out those 3 steps to you is because each one of those steps actually has its own name for it. So when you do the first step, when you subtract, we call that the absolute error. So if you're in a test question and they say, what is the absolute error? You just do step 1, which is to subtract. The relative error is when you then divide by the exact value. So step 2, when you divide by the exact value, that leaves you with the relative error. And then the third step, when you multiply by 100, gives you the percent error. So anytime you multiply by 100, that's how you convert a decimal into a percent. And so by multiplying by 100, that's just the final step of coming up with percent error. But each one of those 3 has its own special vocab name. You need to know what those are because you're going to see that on our test. I will ask you the 3 steps, and the first step will say, what is the absolute error? So you need to know that for that question, all you do is the subtraction step. For the second step, when it says, what is the relative error? Well, then you need to divide this answer by the exact value and get the relative error. The third step will say, what's the percent error? And then you take your answer, multiply it by 100, and now you got the percent error. So I want you to know what those 3 steps are called so that you can appropriately answer those questions on our test. So here's a couple examples, pretty short, but it's a pretty simple formula. You just got to be familiar with the vocab so that you just answer things properly. So if we were to discover that the true measurement of something were 26.975, and we had rounded that off to about 27, here we go with our 3-step process. So again, if you were only asked for the absolute error, all you take is the first step, which is the subtraction step. So we're doing the approximate value minus the exact value, and that gives me 0.025 which is the absolute error. Let me jump down here to the bottom so you can see how this would continue on. So when you do the subtraction step, again, that gave us the absolute error. When you divide that by the exact value, you now have the relative error. And when you multiply your relative error times 100, you now have percent error. And so those are the three steps that we do in order to come up with percent error. On an IB test, all they will ever ask you for is the percent error. And so this is what you would come up with. And on most of our tests, that's what I will do too. This question comes up down the road in future tests as a review problem. So I want you to be familiar with this formula. But on future tests, all I ask for is the percent error. But on this current test, you'll be asked for the three parts. So I want to make sure you know what those three different stages are called. Typically, keep in mind we should be doing this to exact or 3 sig figs. This is not 3 sig figs. So that's just something you got to be aware of. Make sure you're sticking with proper ways of writing our answers. So here's one more case. Example 2. If I had a number like pi and 3.14, again, make sure you identify which one of those is exact and which one of those is approximate. We know pi is an exact number, right? Approximately, it's about 3.14, but this is the exact value. This is the approximate value. And so again, the first stage on that when you subtract is called the absolute error. And here's what we have to 3 sig figs. If we were to continue on, so we started, here's what the entire process would look like. So we started out by subtracting to get the absolute error. We then divide it by the exact value to get the relative error. And then if you do your relative error times 100, you get percent error. And this is what our answer should look like appropriately to 3 sig figs.